Hey, you. Yes, you. Welcome to DBS 10012 Engineering Science. For topic 5, we will go on solid and liquid. Let's go. Okay, so guys, these are some of the characteristics of solid, liquid, and gas. Let us say particle arrangement. So for solid, it is tightly packed, usually in a regular pattern. For liquid, it is close together with no regular pattern, while for gas, it is well separated with no regular pattern. For particle movement, the solid will vibrate or jiggle, but generally do not move from place to place. For liquid, the particles glide on each other freely, while for gas, the particles move freely at high speeds. If we will look at shape, okay, for solid it is fixed, while for liquid it changes according to the shape of the container, while for gas, shapes changes according to the shape and volume of the container. If we were to look at volume, okay, so for solid it is fixed, for liquid it is maintained or fixed. For gas, the volume changes according to the shape and volume of the container itself. Whilst if we were to differentiate between the particle bonding for each solid, liquid, and gas, for solid it is strong forces, while for liquid weak forces, and gas very weak and negligible forces. So those are some of the characteristics and differentiation according to solid, liquid, and gas. Okay, so what a nice infographic we have here. It is on density. So density is mass per volume, and the SI unit used is kilogram per meter cube. Okay. What is the explanation of density? So density is the characteristic of the material. So the formula, okay, back to the definition, is mass per volume, right? Rho equals to m per v, right? And for your information, and this is quite an important information, bear in mind that water has 1000 kilogram per meter cube density. Again, please bear in mind, water has 1000 kilogram per meter cube density. So to further explain what I've mentioned earlier on density, okay, if we were to say coin is heavier than toy, in science we say it, coin has higher density than toy. I'll give you another example, right? Okay, so if we were to say red water is lighter than golden syrup, but what we really mean is, by using science sentence, okay, is red water, okay, according to the diagram, okay, on the figure, red water has lower density than golden syrup.
Let's do the exercise of solid and fluid. This question wants you to calculate the density of the chocolate. Try to remember the formula of density. Write the formula rho equal to m over v. List down the data from the question. Mass equal to 200 gram. And volume equal to 10 centimeter cube. Insert the value from the data. Rho equal to 200 divided by 10, and the answer is 20 gram per centimeter cube, or 20,000 kilogram per meter cube. If the instruction asks you to give an answer in kilogram per meter cube, you need to convert it as taught in topic 1. Next question. List down the data that is given. Roll equal to 1160 kilogram per meter cube. V equal to 1.39 times 10 power of negative 3 meter cube. We use the same formula as question 1. Roll equal to m over v. Just change m as subject. M equal to roll v. Insert the value from the data. 1160 multiply with 1.39 times 10 power of negative 3. So the answer is 1.61 kilogram. If question asks you volume, so just change volume as subject. V equal to m over roll.
Relative density. Okay. So it is known as specific gravity of matter. Okay, the definition is the ratio of its density to the density of water. Did you remember what I've mentioned earlier? The important information? Density of water. So the density of water, raw water, equals to 1000 kilogram per meter cube. And the formula for relative density, rho relative, is the density of material divided by the density of water. Again, what is the density of water? 1000 kilogram per meter cube.
We go to the next question. Here, you have to use two formulas. Material density formula and formula of relative density. First, you have to find the material density. So, write the formula rho equal to m over v. Insert the value from the data. Rho equal to 0.2 divided by 1 times 10 power of negative 4. The answer is 2000 kilogram per meter cube. Then, determine the relative density. Use the formula of relative density. Roll relative equal to roll material over roll water. Given that density of water equal to 1000 kilogram per meter cube, insert the value of material density and water density. So the final answer is 2. Next question is, list down the data. Relative density equal to 10.5 and mass equal to 2.5 kilogram. This question gives data about relative density. So, you have to find the value of material density by using the formula of relative density equal to material density divided by water density. As you know, density of water equal to 1000 kg per meter cube. Insert the value of relative density and water density in the formula. Material density equal to 10.5 multiplied by 1000. So, the answer for the density of silver is 10,500 kg per meter cube. Now, we have the value of density and mass of the silver. So, we use the formula of density. Rho equal to m over v. And change v as subject. Then, insert the value that is given. V equal to 2.5 divided by 10,500. So the answer is 2.38 times 10 power of negative 4 meter cube.
Okay guys, moving on to pressure. Alright, so pressure is forces that act on all surfaces. Alright, so the definition is force per unit area, meaning the forces exerted by a surface act perpendicular. Okay, 90 degrees, the force exerted by a surface perpendicular to the surface. Okay, the pressure cannot push sideways. It must be perpendicular or 90 degrees. And the unit, the SI unit we use is Pascal or Newton over meter square. And the formula is easy. Pressure equals to force divided by area, or P equals to F divided by A.
We go to the next question. This question wants you to determine the pressure. Formula that should be used is P equal to F over A. From this question, force equal to 85 Newton and area equal to 6.5 times 10 power of negative 3 meter square. Insert a value into the formula. P equal to 85 divided by 6.5 times 10 power of negative 3. So the answer is 13,076.92 Pascal. Next question is, this question asks about pressure of the metal. First, find the area by multiplying the length and width of the metal block. A equal to 2 meter times 4 meter equal to 8 meter square. Then, calculate the value of the force. F equal to mg equal to 30 times 9.81 equal to 294.3 Newton. Use the formula P equal to F over A. Then, insert the value of area and force. P equal to 294.3 divided by 8. So the answer is 36.79 Pascal.
Pressure in fluid. the pressure in fluid varies with depth. So pressure equals to force divided by area equals to rho GH, where rho equals to density of substance, G gravitational acceleration, and it has a value of 9.81 meter per s square, and H is depth. Okay, pressure at equal depth is the same. Okay, bear in mind, and pressure or P does not depend on the shape or volume. Okay, if the calculation usually if you have atmospheric pressure taken into consideration, okay, the total pressure in the fluid becomes, okay, the formula becomes pressure equals to rho GH plus, okay, the pressure of atmosphere, okay, P ATM, where P ATM equals to 1.01 times 10 to the power of 5 Pascal. If we were to translate Pascal's principle into formula, okay, it is F1 divided by A1 equals to F2 divided by A2. As you can see in the example of hydraulic car jack, okay, F1 is one vessel and F2 is another vessel, okay, which F1 divided by A1 equals to F2 divided by A2. If we were to arrange this equation, okay, F2 out equals to A2 over A1 times F1.
Question 7 is, this question wants you to calculate the upward force and distance moved by the large piston. This question is about application of Pascal's law. Given the value A1 equal to 0.03 meter square, A2 equal to 0.2 meter square, and F1 equal to 700 Newton. As you learned before, both A1 and F1 refer to small piston and both A2 and F2 refer to large piston. For part 1, the formula should be used is F1 over A1 equal to F2 over A2. Insert the data that is given from this question. 700 over 0.03 equal to F2 over 0.2. F2 equal to 700 multiplied by 0.2 divided by 0.03, and the answer is 4,666.67 Newton. For part 2, given that D1 equal to 60 centimeter. For part 2, wants you to determine the value of the distance moved by the small piston. We use the formula of A1 D1 equal to A2 D2. Insert the value from the data given. 0.03 multiplied by 60 equal to 0.2 multiplied by D2. D2 equal to 0.03 multiplied by 60 and divide by 0.2. So the answer is 9 cm.
Next, we move on to Archimedes principle. So, a body of immersed completely or partially in a fluid, be it gas or liquid, the buoyant force on the body is equal to the weight of the displaced fluid. Okay, meaning that buoyant force makes things seems to be lighter. The formula for buoyant force, FB, not Facebook, FB is the weight of water displaced, where FB equals to mg and FB also equals to rho Vg. So these are the formula that you have to take into consideration when doing calculation for Archimedes principle. Buoyant force. To further explain buoyant force, okay, the figure itself is self-explanatory. Okay, where buoyant force FB equals to actual weight minus apparent weight. Okay, if you were to look at the first beaker, right, FB, okay, the buoyant force is greater than the weight of object. Okay. On the middle beaker, all right, buoyant force equals to the weight of object. Okay, it balances itself, right? Whereas the third beaker shows that FB, the buoyant force, is less, okay, less than the weight of object. Is it easier when you look at figure?
The last question is, this question is about application of Archimedes principle because an object immersed in a fluid. Write the formula FB equal to mg as equation 1, FB equal to rho Vg as equation 2, and rho equal to m over v as equation 3. The data given are mass equal to 0.25 kilogram and volume equal to 6 times 10 power of negative 4 meter cube. Part 1 asks about buoyant force. So, which formula should be used? Okay, we use equation 1 because we has the value of the mass and gravitational acceleration. FB equal to mg, insert the value 0.25 multiplied by 9.81. The answer is 2.45 Newton. Part 2. Calculate the volume of the water displaced. Use equation 2 to solve this problem. FB equal to rho Vg. Change V as subject. Insert the value FB, gravitational acceleration, and density of water into the formula. So the answer is 2.5 times 10 power of negative 4 meter cube. Part 3. Calculate the density of the toy. Use the formula rho equal to m over v. Insert the value of the mass and volume of the toy. Rho equal to 0.25 divided by 6 times 10 power of negative 4. The answer is 416.67 kilogram per meter cube.
Okay, that's it guys for topic number 5, solid and liquid. So I hope you did follow my lesson. Is it okay? But I assure you, if you do exercises on this topic, it will eventually increase your knowledge and understanding on this topic.